but nobody failed. So, you know, I don't want to say, you know, hey, D is a great grade. It's not. We can certainly do better for those that need to do a little bit better. But I will say this, in general terms, the math doesn't get any harder than the last couple sections that we did. But, you know, sometimes, you know, the ability for you guys to really concentrate and pay attention, I kind of question that. And you can get lost really quickly in this material, you know, especially if you're absent, you know, coming back and the kids are talking about things that you know nothing about. I always make it a point that when we do something that involves a hard skill, like there's a calculation or a formula, I always make it a pretty strong point to make sure that we do at least 1, if not 2 days of those particular things. But the logic portion, you know, is something we work on the entire year. Some of you, like half the class, actually got the proof either pointed in the right direction or literally got it right. The other half, not even remotely close. That's what I would hope by Christmas time, when we start doing 2 proofs of test, one will be a really easy one will be a medium one always, that we get to at least, you know, all the class gets the easy one and they at least can kind of, you know, stumble at least to the beginning through a medium one. That's kind of my goal as a teacher. We're going to start a chapter on quadrilaterals. Quadrilaterals get pretty nasty and messy, and there's lots of theorems in this one. So your goal is every single day, stay up with it. Today's an easy day, right? It's not that challenging. Oh, by the way, any questions on the quadratic formula? Okay, I'll collect it here by end of class. Okay. Oh, kudos for paying attention yesterday and sticking with it, because especially if you had not been given a really good introduction into quadratics last year, that kind of seemed like it's coming from the moon or something like that. Today is definitely, I'll get through the day. I don't know how the rest of the chapter will go, but if it goes the way that I intended to go, we'll have a chapter test sometime in 2 weeks. All right, cupcake homework. We're going to get basically 3 statements today, and they're easy to remember. I also, in your book of truth, I want 1 page devoted specifically to the shape that we're going to do today. So on the top of that page, you're going to put big bold letters, you're going to put parallelogram. And then we'll fill in all the stuff that we know about parallelograms. So even though we're going to write the theorems maybe on another page, whatnot, when we say something specifically about a parallelogram, I want it on that page and maybe highlighted, so that when you're taking a test, 2 chapters from now, and it says a parallelogram, you're like, wait, what's so special about a parallelogram? You can flip back through your book of truth and say, oh, I know this about a parallelogram. Does anybody know anything about a parallelogram right now? Like what? Okay, it's a parallelogram. So what? Okay. Well, no, that it's. I know what you mean, but that's not how we would say that. It's not that all 4 sides are parallel. The opposite sides are parallel, right? Anybody else know anything about a parallelogram? Okay, well, I'll teach it to you today. All right, here we go. So properties of parallelogram. And this is, like I said, in your book of truth, give me 1 page. On the top, it says parallelogram. And when I get to that point, I'll say, put it on the page of parallelogram. If I just say put it in the book of truth, it's anywhere that you want to place it. But when I say something specifically about a parallelogram, I'll say put it on the page that says parallelogram. All right, so step number 1, this doesn't have to be in your book of truth, right? We've already said it, and it's kind of obvious because of the name parallelogram, right? A parallelogram is a quadrilateral. A quadrilateral just means a polygon with 4 sides. That's why I said I don't necessarily think you need to put that in the book of your truth, or your book of truth, because I think you already know that. If you're a quadrilateral, quad meaning 4, lateral meaning sides, 4 sides. If you're a quadrilateral, you got 4 sides. Those sides are made up of segments. Amaya. Okay. Today we're going to be talking about 1 specific type. In this chapter, we're talking about quadrilaterals. 1 specific type. What do these red things mean? They don't mean congruent. It means parallel. So this side is parallel to that side, and this side, 2 of these, is parallel to that one. So we say opposite sides of the quadrilateral parallel. That is what we define as a If it needs to be in your book of truth on the page that says parallelogram, put it there. If not, if you were like, well, duh, what else do you think a parallelogram is? Then you just need to write it down on just general notes. But for me, if I had a page marked parallelogram, that would be the first statement, right? A quadrilateral with both pairs of opposite sides parallel. If one set of opposite sides are parallel, we call that a trapezoid. A parallel has both sets of opposite sides. Everybody okay with the word opposite side? Okay. How do we name a parallelogram, Connor? Okay. How do we name a parallelogram, Cadence? How do we name a parallelogram? How do we name a parallelogram, Seth?
The opposite sides.
No.
No.
How do we name a parallelogram? What do you got, Matt?
By its four corners.
By its four corners.
That's so easy.
You pick a corner. Karis, pick a corner. A. You can either go clockwise or counterclockwise, whatever floats your boat. You give me all the vertices. So what's the name of this quadrilateral? A, B, C, D. She also could have said A, D, C, B. She chose C, could have been C, D, A, B. I'm not going to go through all the possibilities. There's lots. Take a guess, wild guess of what the symbol for a parallelogram is.
A mini parallelogram.
A mini parallelogram. So this is parallelogram A, B, C, D. And there's lots of other names for it. We're not going to go through them all. But you do have to name all the four vertices. And they have to be in that order of either clockwise or counterclockwise. But you can start with whatever vertice you want. Okay? This is probably the extent of your knowledge about parallelograms, because up until high school geometry, this is all you're basically told about a parallelogram. All right, another definition. Doesn't have to go into your book of truth. I'm going to use these things here in a second. So consecutive angles. There's going to be two definitions in box 3. Consecutive angles of a quadrilateral. A consecutive angle, somebody pick a vertice. Somebody pick one.
B.
B. A consecutive angle would be any angle that's next to A. So what angles are next to, I'm sorry, I'm pointing to B. What angles are next to A? B and D. So if I give you angle B, what are the consecutive angles? If I give you B,
C and A.
C and A. Okay, those are called consecutive angles. Yes. Sure. One other definition. We have consecutive angles. What do we call the angle that's directly across from it? We're going to call it opposite angles. Now, you got to be careful. This only applies to quadrilaterals. We talk about a hexagon, right? There's adjacent angles for sure, but opposite angles is a bit hard to define. What's an opposite angle of a hexagon? Well, there's a couple of them that are across from it. So we're going to define an opposite angle of a quadrilateral as the two interior angles that are not next to each other. So basically, it's just the opposite of consecutive angles. So I need the angle that's not next to B. Well, A and C are next to B. So therefore, D is the opposite angle. So the opposite of B is D. Now, just like when we did, remember SAS, ASA, I defined sides and the included or the excluded angle. That's kind of where we're going with this. We're going to use these two words, consecutive or opposite, in defining some theorems, which is why they give you these two definitions. So it's kind of intuitive. Consecutive, okay, makes sense. Opposite makes sense. Doesn't make sense in a hexagon for opposite, but it does make sense for consecutive. We okay with that?
Yeah.
Moving on. Okay, let's do a proof. Oh, by the way, all of you can do this proof. It's an easy proof. All right. What's that symbol mean? Parallelogram. So I got parallelogram E, F, G, H. I'm trying to prove that it looks like that this side is congruent to this side. Look at my hands. I'm trying to prove that this side is congruent to this side. So what am I really trying to prove? If you have a parallelogram that what? Opposite sides are the same. They are congruent. I'll say that again. I want to make sure everybody's paying attention. We're about to prove that if you have that opposite sides are congruent. We know by definition they're parallel. That's why it's called parallelogram. But we're going to prove that opposite sides are congruent. Ready? Okay, well, we got the given, obviously. Well, there's not much. It just says that it's a parallelogram. I need to prove that opposite sides are congruent. All right. What's our tried and true technique to show that things are congruent? No. We got a better technique now. Say it again. Make triangles. What did I literally say we will do the entire time? Danny, I know you're drawing a nice picture there, but you got to be paying attention. What did I say we're going to do the rest of the year in geometry? When I show two things are congruent, I'm going to show that they're part of two different triangles, and then I'm going to show that the two triangles are congruent, and then I'm going to claim that is the proof in all of high school. Okay, so let's do that. Where do you want me to draw the line?
From E to G.
Okay, let's draw a line from E to G. So construct segment EG. Now, since it's construction, I make it red, make it dashed. You can make it solid. It's not that important. So I made that. What allows me to do that? I can construct things. I can take my straight edge and I can connect E to G. Good. All right. The next step is the one I got to help you with. You're going to get the, oh, you want to say something?
Can't you say that?
We certainly have a reflexive property. We'll use that here in a second. Okay. All right. Watch what I'm about to draw. What did I just draw? I drew a transversal. So if this line is parallel to this line and I have a transversal, what can you tell me about this angle and this angle? Because they are, it's a parallelogram. So what can you tell me about F, G, and EH? They're parallel. What can you tell me about the red line that I just drew? So therefore, what can you tell me about this angle and this angle? Because they're alternate interior. Turn your head to the right. What can you tell me about this side and this side? I got a transversal. What can you tell me about this angle and this angle? Because they are. That's what we're about to do. Now, in order to do that, I got to name those angles. All right, see my picture? I got to name those angles. So what the heck is the name of that angle right there? I could call it FEG. I'm lazy, so guess what I'm going to do? I don't want to have a whole proof of nothing but 3 letters, Danny. Come on, buddy. I don't want a proof of nothing but 3 letters, so what am I going to do? I'm going to give it a special name, and it's not going to be Fred. I'm going to name those 4 angles, and you can name them in any order you want. So I'm going to name them angles 1, 2, 3, 4. Okay? And there's nothing special about how I named them. I could have named them 7, 8, 9, 10 in any order I want. It just makes my life easier. If not, then you literally have to say angle FEG, 3 letters. And you're going to say this a lot, so I'm going to take the time. It's just called labeling to make my life a little bit easier. Okay? So what do you want me to say in the next statement? What did you tell me? 3 is congruent to 2, and 1 is congruent to 4 because. Okay. I tried to make my arcs this time. It was an attempt. What did you want to say, Cadence? So EG is congruent to EG. Remember, it's that same old thing, reflexive property. Remember, our goal here is to show that the 2 triangles are congruent. Bailey, you're on. Why are those 2 triangles congruent? You can do this. Just read what we marked. Look at one triangle and read what we marked. This was on your test 2 days ago. Read what is marked. How do you prove that triangles are congruent? 5 ways. Tell me them. Tell me the 5 ways to prove that triangles are congruent. So why are those 2 triangles congruent? Boom. Done. And when I say read what's marked, I meant read the red part that we marked. A, S, A. Done. So those 2 triangles are congruent by ASA. Therefore, why is EF congruent to GH, or whatever I named it, because of CP/CPC. Okay? And we're done. That's pretty simple. By the way, what did we just prove?
No, it's parallel.
What did we prove? If you have a parallelogram, you can't say all the sides are congruent. The opposite sides are congruent. All right, good job, QED. That's theorem 5.1. I want you to put that in your book of the truth on a separate page. And then flip back to your parallelogram page, and I want you to put statement 1, opposite sides are congruent. So you're going to have it written twice. And that's just why we got we're going to get a lot of theorems this chapter. I want you to be able to flip through just one page that says parallelogram and be able to say there's technically 4 statements we're going to be able to make. Theorem 5.1 says that opposite sides of a parallelogram are congruent. You don't need to color them if you don't want to. Opposite sides of a parallelogram are congruent, and you just proved it. And that was pretty good. So if you have ABC or parallelogram ABCD, and the opposite sides are congruent. Generally speaking, this is a memorable one. Opposite sides are parallel. Well, that's by the definition of parallelogram. But opposite sides are congruent. We proved it. So you're going to write down in your book of truth theorem 5.1. And then on the page that says parallelogram, you're going to put statement number 1, opposite sides are congruent. I mean, technically, statement 1 should say opposite sides are parallel. That's the definition of parallelogram. But the real statement, the one that we're going to use mostly, is that opposite sides are congruent. Occasionally, we'll use opposite sides are parallel, and we'll do like alternate interior or same side interior or supplementary. All right, we good? Everybody? Danny, you got it written down? Good job. Another proof. What am I trying to prove here? Just look at the statements. What am I trying to prove? If you have a parallelogram that opposite angles are, guess what this proof is? It's the same proof. No, I don't want you to write it down. It's the same proof, sort of, kind of. Notice, all I'm going to do is literally everything the same. I'm going to make 2 triangles. I'm going to say that alternate interior angles are congruent. I'm going to get to those 2 triangles are congruent in a second. And then what am I going to say? Yeah, but what am I going to say based on those 2 triangles? What am I trying to say? Which ones? I'm trying to say that F is congruent to H. Can I say that now because of CP/CPC? Okay, now here comes the kicker. Based on what we just did, can I say that E is congruent to G? No. Right? Because they're not, I split the triangle up on E and G. Now stay with me. Stay with me. By CP/CPC, I can say that F is congruent to H. That's half of the battle right there. The other half is E is congruent to G. Well, I drew this diagonal right through those. What would have happened instead of doing EG, I would have done, would the proof look any different? You want to see how lazy we are in math? Look at my statement. Well, F is congruent to H, clearly by CP/CPC, and then what does it say? I could have instead drawn FH to prove that E is congruent to G by exactly the same way. So instead of rewriting a proof and having another 7 statements, I kind of say, oh, by the way, I could have drawn another diagonal and done it differently. So it's kind of a cheating step, so to speak, but it's not really, it's the logic behind it. Can everyone follow that? I mean, if I had drawn FH, I would prove that this triangle is congruent to this one, then I could have said E is congruent to G. But the proof would have been exactly the same. Oh, by the way, what did we just prove? Write that in your page on parallelograms and where you put your theorems. If you have a parallelogram, opposite angles are congruent. We will use this a lot as well, too. If you have a parallelogram, opposite angles are congruent. Put it there and then flip back to where you said parallelograms. This is statement number 2. Statement number 1 is opposite sides are congruent. Statement number 2 is opposite angles are congruent. You're 3 chapters from now, and all of a sudden you see you got a parallelogram. You flip back to the page. Oh, that's right. Opposite sides are congruent. Opposite angles are congruent. It kind of at least gives you some help on trying to do a harder proof based upon if you have a parallelogram or not. Eventually, we're going to have 4 of these statements. Today, we get 3 of them. Good? All right. You're going to do this proof for homework. This is Theorem 5.3. This is going to be our 3rd statement on the page of parallelograms. Theorem 5.3 says, if you draw diagonals of a parallelogram, you see my 2 diagonals? It turns out that they bisect each other. What does bisect mean?
Meet in the middle.
They meet in the middle. In other words, they cut each other in. If they cut each other in half, what can you say about this piece and this piece? What can you say about this piece and this piece? What we can't say is that those 4 pieces are congruent to each other. I will draw a really crazy parallelogram. You see that parallelogram? Right? They're not, the pieces are not equal to each other, right? If I squeeze it together, make it really skinny, it's a bit clearer to see. But we're not claiming that this piece is the same as this piece. Okay? If you make these 2 come together, then this piece gets shorter and shorter and shorter, right? Where this one could remain long. Okay, so we got 3 statements now. What are the 3 statements about parallelograms? Opposite sides are congruent, opposite angles congruent, and the diagonals bisect each other. The diagonals bisect each other. That's our parallelogram. That's our parallelogram. So we got opposite sides are congruent, we got opposite angles, we got diagonals bisect each other. We get 1 more, we just won't do it today. This was a good class on a Friday because there wasn't much to go over. Let's take a look at what homework looks like.
Oh boy. 1 through 4.
Here's a harder one. Parallelogram, yes?
No. Yes.
Y is G supplementary to M. Ooh. Why are they supplementary? 2 parallel lines cut by a transversal. What can you tell me about this angle and this angle? They're not. They're same side interior. You're going to have to really flip back to remember this one. What do we know about same side interior angles? They're supplementary. By the way, this is the 4th statement we get about parallelograms, is that consecutive angles are supplementary. We'll write that down, not today though. Okay? Suppose that M is a right angle. What can you tell me about G, R, and A? Okay, let's go back to our 3 statements we had about parallelograms. What do you know about opposite angles? Well, that one's got to be 90. What do you know now about consecutive angles from that 1st statement? Which means if this is supplementary to this, then And that's 90. What do you know about opposite angles? So if one of them is 90, what can you tell me about all of them? For parallelograms. Oh, by the way, that's why a rectangle has 4 right angles, because it's a parallelogram. And if it has 1 right angle, they're all 4 of them are right. All right, these are more like the ones that might give you some problems. Okay. I don't know how well you can see this. It didn't come out that clear. But I got an X, a Y, and a Z. X, Y, Z. You see it? It's going to require you to put together some thoughts you had before. Now, Bree didn't have this before. If this is 65, how big is this? If this is 65, how big is this? No. 180
minus 65?
Minus 65, whatever that works out to be. 180 minus 65 is what, 115? Is that right? Right. If this is 115, I'm not pointing to X. What is this one? So how are you going to figure out X? And this is why geometry is fun. It's because all of a sudden kids starts to click, and they're like, "Oh, I see the straight line," right? All right, so that one isn't that challenging. Parallelogram. If this is 56, then that's. Hey, what do you see? What's the shape here? So if this is 56 and this is 85, could you calculate this? This is the hard one. What do we know about these 2 angles and this one from the previous statement? What do we know about these 2 angles and this one? Any consecutive angles are supplementary. So this one is the hardest one. Well, we got to do this. So if this is 56, then this is 56. So I got 56, 85. Somebody do the math for me real quick. What are we left with?
What is Z, the 85?
Well, we're going to find out here in a second. Right?
141.
And then subtract it from 180.
93. Or 39.
So 39? I'll go with it. 39. So we know that these 2 angles plus this one must be, and only one of them is X, so we could solve. This one's a hard one. So it'd be 56 plus X, or Z, whatever it is, Z. You claim the other one's 39, I'll go with that. And then they're supposed to equal 180. You can solve that one pretty easy. So that one's the hard one. And then you would do that one similarly. Or you could say that these 2 add together has to equal these 2. Okay? How about this one? So therefore, X is 110. Here's a killer. 2 parallel lines. Oh, sorry, 2 parallel lines cut by transversal. This is 70. Z is 70. If this is 110, this one is. If this is 110, this one is 70. So I got 70, 70. You can figure out the last one. So we almost use almost everything that we know to get to those. All right, what time we get out of here? It's Friday. Get out of here at 9:54. We got 6 minutes left. Let's continue. Today was going to be a short class. All right, open up your books. Look at number 20. Apparently, I wanted to show that to you. Must be a hard one. What's the page? All right, number 20 or 20. We have a parallelogram. This time, instead of dealing with angles, we're dealing with angles and sides. What do we know about the diagonals of a parallelogram? What do we know about the diagonals of a parallelogram? They bisect each other. So this piece says 28, and this piece says 2y minus 8. So what are you going to do?
The 28 is as a transversal of 20 bottom 20.
What do you know about the diagonals of a parallelogram? They're not congruent. They bisect each other. If they bisect each other and this is 28, what does this one have to be? 28. So you can set this equal to this, solve for y. I believe it says solve for the value of x and y. The other side is done similarly. Can't say that word. All right, so I wanted to show you that one right there. There's a bunch of those. All right, we'll call it a break right there. I do want the homework, absolutely. Danny, where's your work? All right, make sure that you show me all your work so that I can help you. Things you got to write.
Just making sure it's last.
You did get everything wrong, because everyone has two answers. Bailey, you weren't here. All right, make sure you get your homework done. You may require my assistance in order to do that. I'll just say the rest of the kids in here, selected ones, are really good at this. So you can ask them for help as well too. Turn in your homework, Queen. Queen Flower, what?
Princess Bonita. What's your queen name?
It's Princess Bonita. That's
Princess Bonita?
Yes.
The beautiful princess?
Pretty princess.
That's a pretty princess. P squared. You have a third P. You need another P in that name. Pretty purple princess. Pretty pink princess. You're P cubed. Plus your notebook's pink. All right, e-learners, any questions? Nope. Okay, I'll see you guys next